A lot of us meet Einstein as an equation, E equals mc squared, but his story begins as a question a child wouldn't drop. A small boy holds a compass in his palm. The needle turns, and he stares like the room just whispered. No strings, no pushing, no visible gears, yet the needle knows where to point. That moment plants a lifelong habit. When something feels mysterious, don't rush past it. Live there. Years later, people will call him a genius. He'll call it something simpler, staying curious longer than most people do. It started with a compass and ends with an equation. In between is a life of careful attention that changed what obvious even means. And by the end, the equation will feel like a footprint, not a shortcut, proof that wonder can leave marks on the cosmos. Albert Einstein is born on March 14, 1879, in Ulm, Germany. He grows up mostly in Munich in a practical, working family. School, at first, is not a stage built for him. The pace is rigid, the answers are prized, and curiosity is inconvenient. He doesn't sparkle in the way teachers expect. He thinks slowly, then deeply, as if a telescope needs time to focus. At home, he reads what he loves: science books, puzzles, and big ideas that don't fit neatly on tests. As a teenager, he sees a problem with his future. He doesn't want a life built on obedience. So he leaves Germany for Switzerland, not as an escape, but as a young man choosing air. In Zurich, he studies at the Swiss Federal Polytechnic, today's ETH Zurich. He learns physics and math, and also how to argue with a chalkboard. He finds friends who match his pace. They talk late, question everything, and trust honest confusion. After graduating, he looks for work. And then, quietly, a door opens. No prestigious university job appears. For a while, he scrapes by on tutoring and temporary work. This part matters more than people admit. It teaches patience without bitterness. Then, in June 1902, the Swiss Patent Office finally calls him. Confirmed June 19th, and on June 23rd, he begins work in Bern. His job is to evaluate inventions, which is a polite way of saying, find what's wrong with brilliant ideas. Day after day, he reads mechanisms and claims. Between stamps and signatures, his own thoughts keep moving. He later calls it a worldly cloister, a place where the mind can become unreasonably free. He isn't surrounded by lab coats and applause. He's surrounded by paperwork and an unquiet mind. Then 1905 arrives, and his spare time thinking breaks into daylight. 4 papers, each one a door few suspected was there. First, the photoelectric effect. Light, he argues, can act like discrete light quanta, what we later call photons. Second, Brownian motion. He explains the jittery dance of tiny particles in a liquid. That dance becomes evidence that atoms are real, not just a useful idea, actual pieces of nature. Third, special relativity. He asks what happens if you chase a beam of light. The answer is unsettling and beautiful. Time and space adjust, so light's speed stays constant. Relativity isn't a shrug that says anything goes. It's the opposite. The rules hold steady, even as clocks and distances adjust. But clocks don't tick the same for everyone. Seconds depend on motion, as if the universe changes tempo with you. And then a final compact thunderclap. Mass and energy are 2 forms of the same thing. E equals mc squared. A patent clerk in Bern has just moved the furniture of physics. The room will never look the same. 1905 made him famous among physicists. 1915 would remake the shape of the universe. Einstein's ideas spread slowly at first, then faster as other scientists realize what he's done. But his mind is already chasing a bigger prize. Special relativity handled motion. Now he wants gravity. Newton's gravity is powerful but incomplete. It treats gravity like a pull across distance. Einstein suspects something deeper. What if gravity is not a pull, but a change in the stage itself? He imagines space and time fused together. Spacetime. Mass doesn't tug from afar. It reshapes distances and the flow of seconds nearby. In that geometry, straight stops meaning what you think it means. Objects follow the closest thing to straight, inside curved spacetime. So falling isn't just being yanked downward. It's motion guided by the contours of the cosmos. In late 1915, he completes general relativity. On November 25, 1915, he submits the final field equations. Light should bend near massive objects. Time should run differently in strong gravity. It's bold, it's elegant, and it makes the universe feel less like a machine and more like a landscape. A theory this large needs a test, and nature provides one in 1919 during a total solar eclipse. During an eclipse, stars near the sun become visible. Einstein predicted their apparent positions would shift because light bends. Expeditions measure the starlight, and on November 6, 1919, the results are presented in London. The measurements are reported as consistent with Einstein's prediction, and the headlines erupt. Suddenly, the public has a new kind of celebrity, not for singing or sport, but for bending space-time with thought. There's a quiet irony in it. The man who redefined time suddenly has far less of it to himself. A few years later, the Nobel comes for 1921, and it's not the prize most people expect. It honors his work on the photoelectric effect, and he receives it in 1922, but not for relativity. In a way, it fits his life perfectly. The most famous idea wasn't the one that earned the trophy. Committees like certainty, and Einstein specialized in changing what certain even means. Even without that particular medal, the impact was already undeniable. Relativity had retuned astronomy, physics, and the very meaning of measurement. And yet, he remains unmistakably human. Warm, stubborn, occasionally messy, often kind. By the early 1930s, life in Europe becomes unsafe for him. So in 1933, while in the United States, he chooses not to return. He joins the Institute for Advanced Study in Princeton. America becomes the place where he can work, teach, and breathe. He becomes a U.S. citizen in 1940, and he keeps doing what he always did, asking relentless questions. He searches for a unified field theory, one set of laws beneath everything. He also wrestles with quantum mechanics, not out of dislike, but because he keeps searching for a description that feels complete. In December 1926, he writes to Max Born with a famous complaint. The theory works, yet he doubts nature is ultimately ruled by pure chance. He's often seen walking in Princeton thinking. The questions keep pace with him. Ideas don't stay in notebooks forever. Sometimes they grow consequences. One later decision becomes widely discussed, a place where intellect brushes against history. In August 1939, he signs a letter to President Franklin D. Roosevelt. The warning, nuclear chain reactions might lead to extraordinarily powerful weapons. Einstein does not build the bomb. He is not part of the Manhattan Project. but he later regrets helping sound the alarm. Because once a possibility enters the world, it rarely stays theoretical. It isn't a verdict. It's the uneasy fact that some ideas don't stay theoretical once the world can build them. So he speaks more about restraint, cooperation, and human life. The compass needle still matters, especially when the force is invisible. Einstein remains in Princeton until the end. He keeps working, even when the public assumes it already understands him. He dies on April 18, 1955. But his work doesn't fade. It threads into modern life. GPS, for example, must correct for relativity. Without correction, satellite clocks gain about 38 microseconds per day. That drift equals roughly 11 kilometers of range per day. So navigation breaks fast if it isn't corrected. If that sounds abstract, consider this. The maps on our phones work because those corrections are built in. E equals mc squared says matter is concentrated energy. It's nature's way of storing enormous power in a quieter form. Physics keeps testing general relativity, and over, nature nods back. Yes, the curve is real. But the most important legacy isn't technical, it's a posture toward life. Einstein shows us that progress can be gentle, that a revolution can happen at a desk in silence, without permission. He didn't begin as a perfect student. He began as someone willing to look longer than most people do. By now, E equals mc squared isn't the headline, it's what's left behind. The story is how a quiet question became something the universe still answers. And in the end, the compass was practice. He spent his life learning how invisible truths can still point somewhere. The story is a human being choosing wonder repeatedly, choosing questions over comfort and clarity over applause. What remains is a way of looking, patient, curious, and unafraid of not knowing yet. In that kind of attention, the cosmos slowly gives up its secrets. Quiet questions still point somewhere. The compass was only the beginning. You're always welcome here at Illumentary.